Hi everyone and welcome. I'm Marcelo Tribuj, CEO and founder of Truelogic. Many of you maybe know me already, but I'm a software engineer. I'm from Argentina and I started this company 21 years ago. Back when I was just a kid with a passion for building technology that makes a difference. Today, at Truelogic, we are a team of over 600 senior engineers, and we have built a culture of excellence, collaboration, and long-term partnerships with our more than 80 clients. So before we dive into today's insights, let's take a quick interactive poll to get a sense of where everyone stands. Because the truth is, AI is no longer a future trend, it's reshaping how we work right now. So how prepared do you feel for its impact? We'll explore how to move from anxiety to action. But first, here is our opening question. Do you feel your team is fully taking advantage of AI's capabilities? So it looks like 64% feels like they are learning as we go, right? Which gives us a great starting point for today's discussion. So yet, despite all the investments in AI, most initiatives still fail to deliver tangible results, right? And that's why we are here today to share what truly drives success and how to turn AI from a promise into a performance engine. Joining me today is Gabriel Kotliar. Again, many of you probably know him, a global technology leader and chief technology officer at Truelogic, with over 20 years of experience driving AI strategy, software architecture, and digital transformation across industries. He has led a global AI innovation projects for Associated Press, GameStop, Johnson & Johnson, and many, many, many others. And also with us is Ricardo Mañaes, Truelogic's AI architect. He's from Brazil, with more than a decade of experience as a data scientist and machine learning engineer. Ricardo has led and supported teams across Latin America and global organizations such as Experience, ThoughtWorks, and iFood, again, among many others, helping them turn AI pilot into real-world impact. He's especially passionate about figuring out why things don't work so they can. And together, Gabriel and Ricardo bring deep technical expertise and practical experience from hundreds of AI projects around the world, and I'm excited for you to hear their perspectives today. So I would like to kick off by asking Ricardo. We keep hearing reports from MIT in the last few weeks about how AI pilots fail to move the needle on the P&L. Why is that, and what does failure actually means in this context?
Yeah, thanks for the introduction, Marcelo. First, I believe your question is really important at this start because sometimes things look like success from different points of view, but might not be. And it's a common issue, like in which many organizations focus on the technology, on the AI model, and not necessarily the outcome of the business result. A project might produce a technically accurate AI model in the end, but if it doesn't move the needle on revenue, cost, or efficiency, it's still considered a failure.
So failure isn't always about whether the model works, right? I talk a lot of CTOs whose boards are pushing them to do something with AI, right? But there is no real strategy behind it. So it feels like adoption is high, but the truth is that most of the tech leaders still feel lost. They don't know where to start or how to make AI actually work. So, well, the key thing here is that, right, how we use AI to move the business forward.
Yeah, building on that, my question for Ricardo will be, where are organizations failing in preventing those issues? What do they need to do to make that happen?
Yeah, well, it's important to know where. The MIT report brings us visualization for that. This is a plot that came directly from the MIT report. It's interesting to note, I believe I highlighted a part of it because the MIT report includes investigated and piloted projects. And between those two phases, those two initial phases, we can notice a 40% drop. The biggest drop we can see in this plot. So I call for as well that Harvard refers to this as an AI experimentation trap. So project fails at these steps because normally they lack a clear strategy and are not integrated into businesses' processes. And some of the typical issues on this situation is like poor data quality, poor software development skills or talent gaps, also lack of feedback integration through the development cycle, and finally, the lack of adoption or lack of commitment. Maybe, Gabi, do you have any, can you help me out here?
Yeah, so what I understand out of that is not only about the model, it's about all the things around it, right? Like data that comes into the model and adoption once the model is deployed. It's about embedding AI into the organization, being intentional about handling the risks.
Right. So after listening to you, sorry, I have a big question that leaders are asking and facing over and over again, which is how do you integrate AI into workflows without disrupting operations? Ricardo, what's your take?
As I mentioned before, like even technically perfect models can fail if employees don't trust them or don't use them. I'll share again an image that it's again from the MIT report. There are 5 main pointers that it shows, it highlights for us. I would like to call our attention to the first one, change management. Like leaders should prepare a change management procedure. And the first question for this is to understand if the project is easily integratable or iteratively adaptive throughout the processes, or even disruptive if needed. This change management, then communication and training as well, are essential to ensure that the model or the system gets used. So this integration is critical.
Exactly. You can just drop AI into existing systems and expect adoption, right? So thank you, Ricardo. Very interesting. And this prompts me to ask, where do leaders often go wrong thinking AI is just like any software project? We can see this happening in many of the projects we worked on.
Yeah, we definitely saw that. And this is why AI is different. It's probabilistic. It produces forecasts, not warranties. So that's a fundamental project from a product perspective. And leaders have to think about AI as value scoped. This is what good looks like is fixed. That part is fixed. The path to that path, you have to learn it. In traditional software, it's based on scope and requirements, and the path is already defined. And the effort are there, and dates to deliver the software are more predictable.
Yeah. And then I would like to go back to what Marcelo said at first. And I have another visualization for us just to help. Here, I'm using this diagram. It is from the book of Deep Learning with Python from Francois Chollet. In the figure 1, the above one, we see the 2 different visualizations of classical programming and machine learning. And then when we think about classical programming, we can think about the specialist systems from the 1980s, where they were all about hard-coded rules provided by specialists, analysts, consultants, leaders. These rules embedded into existing systems provided the answers that they required. Nonetheless, building up these rules were time-consuming and costly. And for newer applications, this is unfeasible. Machine learning is an area of knowledge that for building rules or machine learning models or models. Successfully building these rules depends on many technical challenges, but this is much faster and cheaper than than the 1980s approach. If we look down on the figure 2, that is an edit from the same image, basically, as you can see. And this represents my idea of what machine learning is. It's a backend for our backends. It's a backend for our data pipelines. It's a backend for our data streams. These AI systems, in terms of integration and maintenance, do not simplify, but aggregate a new set of skill requirements and roles. Data scientists, machine learning engineers, they come into the picture for not only building these applications, but also maintaining them. And then this aggregates to the current existing ones, like software engineers, infrastructure, data engineers, system reliability engineers. All of them are required for guaranteeing procedures of the normal behavior and the normal functioning attitude that we expect of these systems. Then going back to something that you commented about, Gabi, I'd like to chime in as well. Like having my question, and I have a very strong opinion on the answer, is like, when does experimentation end and production begins? As you said, it's probabilistic. So in my opinion, experimentation technically ends when a model meets this business metrics and passes these risk checks. And this can be thought of as evidence gates. That is the first pointer that we see. And some of these evidence gates on a proof of concept, for example, is to have version artifacts, and these are data, code, the machine learning model itself. We can have as well evidence gates for observability, for example, input quality metrics, predictions, observability, and usability, system reliability engineering, the famous latency, throughput, and saturation of the system. And then as well, procedural evidence gates like operational playbooks, thresholds for the metrics that I mentioned, alerts for this as well. And if these alerts come up, actions and rollback plans. So after all of this, we're thinking about evidence gates for a proof of concept. But even in production, the AI, highlighting what Gabi commented, is still in research mode. So the work changes after the MVP is delivered, but it's never done.
So what I would like to take out all of that there's a lot of valuable information, but there's at least some key differences that we can take out of that to understand what's the difference between our usual projects and how managers need to work with AI, right? One is the use of evidence gates, based on metrics instead of delivered functionality. That usually is what structure your work. Did you reach the expectation of what good looks like for the model, right? As Ricardo said, if this is never done, the budget is important, right? When I will stop working on something, do I have more budget to keep improving the model? And same with data. That's another difference. Did you do your diligence on getting the data ready to start the project? And the last question that I have is like to reflect on is what happens if you cannot reach the expected level of trust for that model, right? So you need to have a fallback strategy ready for that case.
Exactly, Gary. One project example is a recommendation systems that I worked on. Basically, our first iteration, the experiment failed because of feasibility checks, like I believe latency, like the response time for the recommendations overall. So that failed at first. And then on a second run, the second iteration, we passed offline checks. And after having passed those, we ran 2-week online A/B testing with guardrails and shadow mode. And only then, after 4-6 weeks of development and testing, we went into production, even then with a 30-day hypercare window and retraining window schedules.
It's fair to say that a manager can count on 2 artifacts to control this or to manage this. Lifecycle plan, that would be one. That's kind of similar to your usual project plan, but not quite the same. It will contain the phases, the gates, the owner's risks. And the second artifact will be a model success and safety specification containing KPIs, metrics, rollbacks, and fallbacks criteria that we mentioned before, and also the list of worst case scenarios.
Great. So this is very technical. Thank you for all this information. But listening to both of you, so prompts me to think that as a CEO, and I'm sure the other C-levels too, ask themselves the same thing. How do we ensure AI actually delivers measurable business value?
Well, that is the golden part, right? The $1 million question. So I would like to bring something that Gabi said before, which begins with trust. And it starts with discipline and visibility during development, during delivery, and after that as well. There are some steps that should contain that. Basically, the first one I believe is labeling, not just data labeling, but the project itself. Like we have to have a clear taxonomy within the team, so stakeholders, everyone involved knows how to name and to define things. There is as well quality assurance sampling. This is a practice that is commonly not seen on machine learning projects. With Gen AI, I'm seeing, I'll comment a little bit more after it, but it's coming more in the picture. And then measure agreement and decision lineage of the project overall. So how do we have a clear line of decision making on that project? Second point is cleaning, like data and code. So to facilitate maintenance as well, reusable transformations in data to guarantee the functionality and behaviors that we expect. And of course, if we have a deployment that is not passing the quality, should be blocked and worked on. After that, we have monitoring, like the final goal is to achieve results on the KPIs, on the business KPIs, but this takes time to compute. Like every quarter, every semester, or every year, we are able to see those results. So before business KPIs, we can think about model performance. There is one issue as well with model performance, because if we are forecasting for the future with these models, we will only have the model performance in that future. If we are forecasting for 6 months from now, we will only know the truth 6 months from now. So before model performance, we also have drift metrics. Drift metrics, there are multiple types of drifts that we can compute, and they can be computed cheaply and fast. As soon as we do the forecast of these systems and these models, we can have these metrics computed, and over time, we can avoid multiple issues with the proper observability and alerting in place with those metrics. So just to summarize, these drift metrics, they're, I believe, a core part of a machine learning engineering role. It's a responsibility, is that drift metrics are a proxy metric for model performance, because model performance takes time to be computed. And model performance are a proxy metric to business KPIs, or that is if they are strategically aligned with the business. Then as well, able to call attention for replicability. If everything that I said goes wrong, we should be able to automatically, or at least easily, retrain a new version of the model. Also, having scheduled retraining windows is a commonly forgotten practice as well. This should be as better as possible automated. I would like to go back to the quality assurance sampling that I mentioned before, that for Gen AI, I'm seeing more and more the terms of golden data set being referred to. And this idea of golden data set is also from the classical machine learning effort, that is to maintain a comprehensive data set for testing. Like if you have a data set that has specific behaviors that are interesting, you should save that for reevaluation of your models. And this basically provides the capability of regression testing, like the model. And this is a core skill that we need to have on our systems that comes from software engineering as well. But in the end, I believe the main takeaway here is if you can't measure the return of investments from the data up, you're probably managing hype and not performance.
And I was wondering, in your experience, what are the risks that leaders tend to miss when they roll out AI projects?
I believe the biggest is overconfidence. Like AI models, as we all said here, are forecasts, and they can be wrong. They're probabilistic, they're heuristics, and operational issues as well can be huge and have a huge impact on the success or not of a project. So without governance, replicability, or hands-off systems, procedures, even strong AI models can fail. I'll show you again a 4-pointer from MIT report as well. I would like to comment or focus on the first one. Learning from failure is a core part of avoiding future issues. And I see too few post-mortem reports and retrospectives happening over the projects that I've been part of. For today, focusing on these 3 learn from failures, I would like to share 3 cases. I also have a visualization here just to guide us through. But the first one is Zillow. Zillow is a company, this case is public. So if you look back, in 2019, they announced the loss of over $500 million and 2K people were laid off from summarizing over-reliance on predictive models. Some point the cause to complacency of an existing open source time series modeling framework. The framework is called Prophet. It still exists nowadays. In 2020, I believe, as a drawback or as a result of this, in 2020, Zillow formed an AI council to oversee all AI development and delivery from their company. The second case, it's a banking that at the time that I was with them, they had 70 million clients. This is not public case, but basically what happened is that the data scientists became maintainers. Basically, there was no hands-off procedure after an AI system was delivered. So the data scientists, without the skills of software engineering, DevOps, system reliability engineering, these data scientists needed to provide maintenance and fix issues on production systems. The result is expected, like the model development velocity stalled because data scientists were putting fires out every day. And the system reliability became a core concern on the organization. They not only took a massive hit on system availability and reliability overall, but data scientist satisfaction was also impacting the employer turnover. Then there's the third case that it's an e-commerce food delivery, not public as well, but it's a company that in its throughput has 1% of the national GDP. They built an in-home MLOps platform that, in the end, it lacked one very known and basic software engineering procedure that technically is correctly tagging the Docker containers. After months and dozens of projects migrated to that internal platform, suddenly all of the systems went offline because the Docker containers were not tagged correctly. They were deleted by an automated procedure. So dozens of AI systems went offline on a Friday night. This caused revenue loss. Dozens of teams worked over the clock to recover those systems for weeks. And because as well, most of those systems had a very low level of replicability.
It looks like making a mistake here could be very expensive, right? And well, I mean, this is obviously a lot of information, and let's see if we can agree to this. So if you want your AI efforts to pay off, I mean, leaders should focus on 3 pillars, right? And then, Carol, tell me what you think. So number 1 is metric matters. So we have to tie AI to KPIs and tangible ROI. Then number 2 is process matters. So have a life cycle with clear decision points and checkpoints. And 3 is culture matters. So foster curiosity, learning, and adaptability across your teams.
That's a great summary, Marcelo. I would like to add maybe to process matters in terms that DevOps found out that there's no trade-off between quality and velocity of development. And also add that AI is not just about the models, the technicality of it. It's about building systems that integrate into businesses. So measure impact and recover safely when these forecasts goes wrong or also the systems fail. So I believe treat AI like a living system, the team as your co-pilots, and the work never stops. We have to measure, to learn, to adapt, and iterate. That's how I believe the 5% succeed.
All right, great. So before we open the floor to your questions, I want to leave you with one thought. AI is not just about building models. It's about connecting them to real business outcomes, managing them as a continuous process, and fostering a culture that learns and adapts. If you keep those 3 things in mind, I mean, you will dramatically increase your chances of being in that 5% of AI projects that truly succeed. Now, we'd love to hear from you what challenges you are facing with AI in your organizations, or if you have any further question. Why do so many AI projects seem to fail even when the technology looks solid? And maybe you, Gary, can take it?
Yeah, I can take this one. I will kind of have to thank you for the question because it will let me say what I think it's most important about this webinar again, and it's something we mentioned several times, is it's about embedding AI into the organization and having a measurable business impact. So if you push something just because of the technology and because the technology looks okay, without having the business in mind, you will increase the risk of failure, definitely. On top of that, something that we didn't mention during the webinar is that machine learning frameworks and non-code tools are making easy, if you want to call it, to create AI-based tools. However, even if the technology looks solid, in many cases it's not enough to deploy something to production. For example, we are about to embark in a project that implies a complete refactor of an AI solution we'll build on top of non-code technologies. The technology was okay, and even it was successful on getting the budget to the project. But now that you need to move to production, we need to rebuild many of those things. So you need to be careful with that. It's about those two things.
Many companies are using AI without even knowing the results and impact, whether positive or negative. So my question concerns the reliability. How can we manage the use of AI to support our functionalities without becoming dependent on it? So the team knows exactly what and how it is being developed, and at the same time, maintaining trust.
That's, I believe, a great question, because it involves not only AI, but also software engineering procedures and the process of delivering a software that is an open question, like whether it will be positive or negative. So it is an experiment. When we have this situation, one thing that I think, like as an engineer, machine learning engineer, statistically focusing, is an A/B test. So thinking about A/B testing, not only on the technical side of it or on the system itself, we are doing an A/B test on the organization. So there are ways of deploying this and having the human in the loop for the forecast of this system will be evaluated for possibly a long period, because you are trying to identify if this is positive or negative and in which metrics of the business. So we thinking about the software itself, when you say the team knows exactly what and how is being developed, that takes a lot of effort, because on the software engineering, like the developers need to maintain a roadmap of development that can be done with semantic versioning, that can be done with future a roadmap of deliverable and milestones, so a full project management context. And this requires a lot of effort. And then the team that is going to be impacted by those changes needs to be aware of them. So they need to receive alerts or deadlines or dates for these future changes that are going to happen, and be prepared for it. So there is a huge cooperation effort, and that goes back to a book that it's called Team Organization for Experimentation. So I will have to remember the name, but I can send you after Topology of Teams, if I recall correctly, the title of the book. So that is if the cooperation basis, and that requires a lot of effort. And also, I believe in the end is have a fallback plan. Like, if it is working, be candid by it, be trustful about it. If it is not working, you as well have to be candid and transparent about it. And maybe if it's not working, there are adjustments that can be done to make it work better. But I believe, if I can summarize everything with something that Gabby said, is what is good. Here we're talking about whether it impacts positively on the KPIs, but possibly the team also has an opinion on that, and that should be transparent as well.
Thank you, Ricardo. And here's another question from Sam, and it's also around what you mentioned before about experimentation. So how do we know when experimentation ends and production really begins for an AI model?
Okay, yeah, well, it never ends. I would say, like, the work changes there is a great comic meme that it's about change or automation from XCZD, like the comics that say that the automation effort is huge to make it work. And then the expectation is that at some point that work or that time effort will be lower than the original effort of the team or of the corporation. But in reality, that might not be the truth. Like in reality, that can even be higher effort because you will need different skills to maintain that. So in the end, the work, the type of work changes after you've delivered an MVP that is using AI. But it depends on what is that model doing, how high the risk of if the model forecasts are bad, how high is the risk of impacting negatively the business performance. So there's a lot to understand, but in summary, in real short summary, it's always in experimentation mode, I would say.
Can I add to that?
Of course, sure.
I think that in a previous company we had a sign somewhere like on a server said like system working, do not touch it, right? And even though that's not true even for traditional software, in this case, talking about models that will work on having an approximate answer, like the best answer possible to a problem, that's more it deviates the truth even more, right? So you need to keep working, keep maintaining this, and keep adjusting things that you don't usually need to do with traditional software. It's about just maintenance, probably, right? Or short improvements. But in this case, you need to keep working, keeping the model improving to get a better answer.
Thank you, Gabby and Ricardo. And we have time for one more question, and I have it here. So it's a question from John. So how important is governance and oversight when deploying AI at scale?
The importance goes all over the risk. Like if the forecasts, like if the risk mapped, like if things goes wrong is low, then you might be at ease, like you can be a little bit more comfortable with maintaining a very close look on what is going on. But if the risk is high, there are many techniques for governance oversight of software and data pipelines and machine learning models themselves. So I would say the monitoring and observability tools should be in place and functional. Debugging as well should be in place and functional. Logging, all of the software engineering practices can be applied to machine learning workflows, pipeline systems, and all. There are specifics to machine learning that I believe the core part of it are the drift metrics. This drift metrics can help out to identify early if something is going wrong. In a recent project that I've been working, there was an issue of IO reading. Like basically they were doing forecast for around 12,300,000 instances every day with a batch job. And because of a hard drive lack of memory issue and race condition between writing and reading from that hard drive and the pipeline and the Python code to submit the results, they were missing around 10% of the scores. So basically, because of an IO issue bug into the pipeline, they were losing these rows. When we set up the row count alert, that is very, very basic, like the input rows were 12,300,000. The output rows should also be 12,300,000, sorry. So we set up this easy alert on the application, and we started receiving warnings. And then we check it out and we identify the cause of the issue. So this type of activities are pretty close to unit testing, to testing, and double checking all of the steps that are going on. So yeah, if the risk is high, you have to go deep on this capability of observability tooling around the system. If the risk is not so high, you can possibly be at peace with it, with a lower level of maturity overall.
There is obviously so much more to explore, and we'd be happy to continue the conversation with anyone who wants to go deeper. So obviously today was just the surface. So again, thank you all for your time and for the great questions. And well, we look forward to speaking again soon or joining in our next webinar. So again, thanks so much for your time, for being here. And well, we look forward to reconnect soon. Take care. Bye-bye.